Welcome back to Josh Does Math. In this video, I'm going to be doing a limit problem that involves the limit as x approaches infinity. So you can see the function here that we're looking at. We're looking at as x goes to infinity. So I'll just plug in infinity for every x and see what we get. We get infinity minus 1 over 2 to the infinity all over infinity plus 1 over 2 to the infinity. And 2 to the infinity is just infinity, and 1 over infinity is just 0. So this becomes infinity over infinity, which is one of the famous indeterminate forms, so that's not the answer. So how do we figure out what this limit is actually equal to? So we'll use a trick that sometimes we use for polynomials that approach infinity. We're going to divide by the highest, not the highest power of x, but by the most dominant term. And the most dominant term here is 2 to the x. So we're looking at the limit as x goes to infinity of, I'm going to write it out one time before we do the division by 2 to the x. I'm just writing it in this form so we can clearly see numerator and denominator, and we get rid of the negative exponents. So here's our function, and I'm dividing by 2 to the x. So that means that these two terms right here become 1. 2 to the x over 2 to the x is 1. And this term is going to become a 2 to the 2x. That's just the power to a power rule, power of a power. So this is what we're left with. Now what happens when I plug in infinity? Well, I get 1 minus 1 over infinity all over 1 plus 1 over infinity, which is just 1 minus 0, so 1 over 1 plus 0, which is just 1. So we get 1 over 1, and that is just 1. And that's the answer to this limit. So that's how you do a limit that results in infinity over infinity. Usually there's a factor that you need to divide by, and sometimes you kind of need to make up that factor. It's not just sitting there. You need to divide everything by some factor so that whenever you plug in infinity, a lot of your terms turn into 0, and then you can figure out what your limit actually is. So thanks for watching.